Today's lesson is about present value of an annuity. In this situation, we have a timeline where we've been putting equal payments in to some kind of investment or something for, looks like in this case, 5 periods. These are equal amounts in 5 periods. And the question is, if we're out here in the future, what are those equal payments worth in today's dollars, which is expressed as time zero? So the way we're going to find this is we're going to use this formula at the bottom here, which is a present value of annuity equals the periodic payment, which are these little dollar signs here equal these, meaning these equal payments, times the table value, and the table value will be in your back of your book, and it'll be called the present value of an annuity. And you'll have to know interest rates and also the number of periods. Here's our first lesson. What is a series of 3 annual payments of $50 starting 1 year from today worth now if the prevailing interest rate is 7% compounded annually? Here's what the picture looks like. You're out here in the future and you had 3 $50 payments made each of these 3 years. The interest rate was 7%. So now the question is, if you discount these back to the present, then what are these payments worth now, right now, in today's dollars or at time zero? Well, is the unknown that we're looking for here, is it in the present or is it in the future? Well, it's in the present because we know these equal payments here, and what we don't know is what they're worth right now. Is this a lump sum problem or is it an equal payments problem? Well, it's an equal payments problem. Which table do we use? Okay, in my book it's called B3, but it's really called, in any of these books, the present value of an annuity table. And we're going to use the information we have, which is 7% for 3 periods. That's up here in the problem, 7%, and there were 3 interest periods right here. And the periodic payment, or the equal payment, was $50. And so we're going to look at that table and get the following table value, 2.6243, and we're going to multiply that times $50. And those $50 payments, 3 of them, are worth in today's dollars $131.22. Now the next problem we've got. What is the present value of investing $3,000 each year for 7 years, earning 12%? So, in this case, the unknown is in the present, and the situation here is going to be a series of equal payments. They're $3,000 apiece, and we're going to use the same table, which is my B3. Could be something else for you, but it'll be the present value of annuity table. We're going to plug in the things we know. We know the interest rate is 12%, number of periods is 7, and we also know that the equal periodic payment is $3,000. The table value becomes 4.5638, and we will multiply that table value times the equal payment of $3,000. Those payments are worth, it looks like, $13,691 in today's dollars. And notice that we actually put up for those 7 equal payment periods $21,000, but because we are discounting those things and taking the interest out of them and bringing it back to the present, that all those 7 payments of $21,000 in today's dollars, since you have to wait to get them, are only worth $13,691. Our next problem. If your company bought a piece of equipment for $30,000, agreeing to pay down 0 and then to make 3 annual payments of $10,000 each at a time when interest rates were 8%, how much should the equipment be recorded on the books for? Well, normally you record equipment on the books for what you pay for it, except in this case, you're getting time to pay for this. You're getting 3 years to pay for this. So you will record the equipment minus the interest that you would have built into those $10,000 payments. So the first question is the unknown in the present or is it in the future? Well, the unknown is in the present. We're trying to figure out how much are $10,000 payments made each year for 3 years worth right now. Is this a lump sum problem or is it a series of equal payments? Well, it's a series of equal payments, and we're going to use table B3, which would be the present value of an annuity. And it looks like if you take 8% for 3 periods and then multiply that times the periodic payment, which is the equal payment of $10,000 for each of these 3 years, the table value is 2.5771, and that multiplied times $10,000 means that the present value of those 3 payments that were a total of $30,000 in today's dollars are worth $25,771. So what we've done is we've taken that $30,000 over 3 periods and we've backed the interest out of that, which means we've backed out $4,229, and that means that you have to record the equipment at what you could have bought it for cash, which is $25,771. The accounting profession will require you to record this not at $30,000 but at $25,771, and the rest of it is interest. And that's the end of the lesson.